vectors, vector diagrams. Okay, the short way to explain how we do most of the vector work is to tell you that basically we go the long way round rather than the short way round. Okay, so vectors can be written in a number of different ways. So for example, at the top here they're telling us we've got the vector OA and they've got an arrow over the top, so that's one way. But the other way they're doing it is they're saying that that equals A, and that's in a bold type, so that's another way of showing that we're talking about a vector. So the difference between a vector and our ordinary numbers is that a vector is not just the length of the line, but it's also the direction that we're going along that line. So that's important here. So here we're told that going from O to A is vector A, and going from O to B is vector B. So we've got A here, B. So we've got O, capital A, E here, B here, C at that crossing point there, D here, F and G. So in terms of the little a and the little b, we're now being asked to write down some other vectors. So they want us to do OC. So here's where C is. Here's where O is. The short route would be to go down the middle. But to describe it as a vector, we have to go the long way. So the long way would be to go up here. So O to C is the same as going from O to A and then going from A to C. Okay, so now what we need to do is work out in terms of the little a and the little b what that means. So O to A we know is the big A, so that's easy enough. Now going from A to C is the same as going from O to B. So I have the same vector because the lengths of the lines are exactly the same and they're going in the same direction. If it had been going in the opposite direction, we would have made it a minus b. So this is just A plus B. That's the vector that we have for going straight from O to C. The next one they're asking us for is B to A. So here's B and we need to go to A. So to go from BA, and I advise you just write down your route before you put in the little a's, b's and so on. Okay, so to go from B to A, we're going to go from B to O, and then we're going to go from O to A. Now, O to B is little b, but B to O will be minus B. So that's minus B. And then O to A we know is A, so it's minus B plus A. The next one they ask us for is D to F. So here's D and here's F. Okay, so we've got to work out what that vector is there. So we've got to figure out how we can go from D to F in a longer route with using what we've got on here. Okay, so what we can see, all right, or I'm trying and help you to see, okay, is that the simple way would be if we knew what these lines were. So that would be telling us that we go from D to F by going D to C and C to F. Now we need some extra information here. So up here at the top it tells us that this is halfway. So that means that that is the same as that. It also tells us that A here is halfway this way. So what that's actually telling us is that this shape and this shape and this shape, they're all the same size basically. And so the diagonal D to F is actually the same as the diagonal in each and every one of these different shapes. So D to F is also going to be the same as A to B. we've just worked out what B to A is. So from A to B, so D to F is the same as from A to B. They're identical in length and direction. And A to B is the opposite of B to A. So that just means we change all the signs around. So now we're going to have plus B and minus A. Okay. The final thing they've asked us to do is to show that the line that goes from E all the way across to G is parallel to the line D to F. Now lines are parallel, like AB is parallel to DF, when they have the same vector, but they might be longer or shorter than each other. So they might be a multiple or a fraction of the vector that we've got here. Okay, so we've just done D to F. So E to G, let's look at that. So E to G would be O to E. Sorry, wrong way round. E to G would be E to O. So E to O, we must get it the right way round, and then O to G. All right. So E to O is double A to O. Okay, so going from A to O is minus A. So this is double that. So that's minus 2A. And then going from O to G, because this is the middle, that's going to be double this. So that's B. So it's going to be 2B. So that's plus 2B. Now if we take that and we factorize it, so we can see we've got a common factor of 2, we get 2 brackets minus A plus B. And just to turn that round, or I can turn this one round, so D to F is B minus A, or which is the same as minus A plus B. So we've proved that these two lines are parallel, because this one here is just double the length of this one, but it has the same vector. Let's have a go at another diagram. Okay, so we've got O, we've got A, got B, we've got D, got C, and there's a point here in the middle that's called E. Now what they're telling us that is that O to A, so going in that direction, is 2A. And from A to B, so going in this direction, is 4B. And from O all the way across here to C, going in this direction, is 8B. Now what else do they tell us here? So they tell us that point D is the midpoint of here. So that's halfway mark here. And they also tell us that E is also in the middle of its line. So that'll be useful later. So the first one that they want us to do is O to B. So let's plan our route. So we've got to get from O round to B. So we're going to go O to A. And then we're going to go A to B. So O to A is 2A. And A to B is 4B. Nice and straightforward. Next one they want is the A to C. So A to C, we're going to go A to O, and then O to C. So A to O is opposite direction, so it's minus 2A this time. I'll write it here. And O to C is the right direction, so it's 8B. So plus 8B. That's A to C. Now they want us to go from A to E. Now this is easy because A to E and A to C are the same vector, the same direction. It's just half the size. So we literally just half this. So A to E is minus A plus 4B. Okay, and then finally they're asking us to show that E to D and O to C are parallel. So O to C we already know. So O to C is 8B. So what we want to show if is E to D is some number times B, then they're parallel, because it's just about how long the line is. The B bit tells you the direction, the angle, if you like, of the line. So let's do E to D. So we've got E to D. So let's see, how are we going to do that? So let's do, which way do I want to go? So the shortest way to go is to do E to C and then C to D. Okay, now we're going to have to come back to this C to D business in a minute, but E to C is going to be the same as A to E because they're on the same line, they're the same length, it's just a different one. So the E to C is the same as A to E, which we just worked out here is minus A plus 4B. So now we want C to D. So before we can do C to D, we need to know what it is to go from C all the way to B. So let's just, I'm just going to bring another piece of paper in here to do some more writing on. Sorry, run out of room there. So we're looking at, we want C to B, because if we know C to B, we know C to D will be half of that. So C to B is going to be, if we go a different route, it's going to be C to O, then up from O to A, and then from A to B. So C to O, we're going against the arrow here, so it's minus 8B. O to A is up 2A plus 2A. And then if we go across here, we've got 4B. So altogether, that's minus 4B plus 2A. Okay. Now that would be going all the way. We only want to go half the way, so we're halving that. So to go from C to D is going to be minus 2B plus A. So now if we take that and put that in to our E to D thing here, so we've got, that's our E to C. So we're now going to put in our C to D, which is minus 2B plus A. So now if we tidy that up, we see we've got minus A there and plus A, so they cancel each other out. And then we've got 4B minus 2B, so that leaves us with 2B. So that proves that ED is parallel to OC because it's just that ED is a quarter of the length of OC. Let's just do one last one then. Okay. So we've got D, F, G, and E. This one is 4A. So from D to E is 4A, and from E to F is 6B. Okay. So the first thing they're asking us for is D to F, and D to F would be D to E and then E to F. D to E is 4A, E to F is 6B. So that's D to F. Now, it tells us here that D to F as a ratio to F to G is 2 to 3. So that in effect, if you like to think of it, that means that whole line is 5. That bit's 2 parts of it, and that's 3 parts of it. Okay, so the other way to sort of see that is that if we take that as one whole line, this bit here is 2/3 of it, and this 2/5, sorry, apologise, and this bit here is 3/5. That'll come in useful in just a minute. So they want us to work out D to G. Okay, now we've just worked out D to F. So D to F, this bit here, which we know is 2/5. So D to F equals 2/5 and equals 4A plus 6B. So then hopefully you can see that 1/5 would be half of that, which is 2A plus 6B. So we want the full line, so we want all 5/5. So we now need to just times everything by 5. So we find that D to G is 10A plus 30B, because it's simply longer than the D to F one. So it's another way you could think of it, I suppose, is it's 1.5 times longer here than here. So add 1.5 of these on. But I think it's probably the easier way is the way that I've tried to explain it. So D to F is 2/5 of the size of the whole line. So if 2/5 is this, 1/5 is that. So to get the full line, we need 5/5, so we multiply by 5. So that's working with vectors.